Good afternoon, everyone. Thank you for joining this presentation. Smart coating are now adding functionalities beyond the basic definition of coatings. They are integrating new functionalities to enhance the coating for a better hygiene and healthy environment, for example. As such, we can mention about self-cleaning surfaces, toxic air pollutants reducing coatings, dust and dirt repellent paints, or antimicrobial surfaces. If we look more into details about antimicrobial surfaces, antimicrobial surfaces or antibacterial surfaces, there are a lot of them. In the medical domain, for example, in the consumer products, we can see plastics, for example, footwear, fridge, home appliance in general are using antibacterial materials. Metals, textile, such as bedding, towels, socks, wipes, toilet paper, shoes, any kind of material, footwear, for example. We have coatings as well in hospital areas, public areas, school areas, baby rooms, food production areas, and other areas. Of course, there are performance claims associated to those antibacterial surfaces, such as antimicrobial in general, antibacterial, just focusing on bacteria, odor control, hygienic. So there are many different claims and performance claim. And of course, we would like to understand how do they work and what do they do. So this is the purpose of this presentation, also to introduce the application itself. If we look at how do we achieve antimicrobial or antibacterial surfaces, the goal is not to protect the coating itself, but to build in an antimicrobial or antibacterial functionality to the material. Antimicrobial surfaces are not an approach, is an approach to improve hygiene in hospital, for example, public buildings, production areas, or even household environments in general. New approach, it's a new approach to use functional coatings and plastic materials or fabrics. It is also not a replacement for cleaning and disinfection. That's very important. You still need to maintain cleaning and disinfection of the material, of course. It's in fact a hurdle technology to reduce the probability of microbe to transfer. So it helps to reduce microbes in the environment. So hygiene is a key idea in modern living environments. We have to remember that, and this is the purpose of antimicrobial surfaces today. If we look at the market of hygienic coatings today, it's a huge and fast-growing trend, and with more and more hygienic conditions coming up. We have seen it recently with the COVID-19 pandemic. There is more and more demand for hygienic coatings. We can see that nursery, public areas, hospitals, assisted living houses are very sensitive area, and as such, there is a need for hygienic coatings in this application to reduce the density of microbes in those areas. Kitchen, bathroom, children rooms are also sensitive areas to take into account. Food and manufacturing areas are also very important to take into account for this application. General interior paints, of course, could be a concern for people who are sensitive themselves. How does it work? You have different ways of controlling microbes into the environment. There could be a kill effect, all right, where you just reduce the amount of microbes by killing effect. So it could be a surface contact kill. So the molecules enter into contact with the microbes. It could be a release of molecules from original molecules, which is going also to kill the microbes. After that, you have different effects by repellents, self-polishing surface, which to some extent the coating is renewed, and as such, you don't have the microbes which are sitting on the coatings are continuously expelled. And also the same for non-adherent surface. So all these are the way to control microbes onto the surface. Next is the Troy approach. To control microbes, we look at what we call IBIT. So the original molecule is benzoisothiazolinone. It's BIT. BIT is a well-known antimicrobial, antibacterial molecule. But of course, we immobilize BIT so that it's maintained in the dry film. Today, BIT is well known in the wet state or in-can preservation. But of course, in the dry film, it's not a molecule normally. We have to immobilize it, and Troy has the technology for that, to immobilize the BIT in the dry film and maintain its efficacy on the dry film. It is worldwide regulatory accepted. It has a very wide regulatory acceptance. It's well regulated today. It's a liquid, it is a suspension, a concentrate formulation when we have such products. So it's easy to dissolve into any antibacterial paints or any emulsion paints, water-based. The optimal use level is actually 500 ppm. So this is really the optimal use level. It depends, of course, on the paint qualities, on the surface qualities. It's not a sensitizer according industry standards, so you can rely on it as well. It's safer to use than some other antimicrobial ingredients. There is no discoloration risk to consider immobilized BIT. And it's heat stable. That's also an advantage of this molecule. There is no issue about compatibility or stability. As we mentioned, it's not only heat stable or not stable to discoloration, it's also compatible in general. And it's reasonable cost compared to traditional antibacterial approach molecules. So now, if we look wider, now we have looked at immobilized BIT, which is antibacterial. If we look wider and then we go for antimicrobial, so in the interior application, we look at bactericide and fungicide for dry film. So if we extend to antimicrobial in general, of course, you can consider immobilized BIT plus IPBC. IPBC is iodopropenyl butyl carbamate. It's also a well-established dry film fungicide. It is very broad spectrum fungicide. It is also it has very wide worldwide regulatory acceptance in the market. Even in Europe, it is one of the most accepted fungicide for dry film application. And it can be combined with immobilized BIT into one product to provide antibacterial and antifungal effect. So this is also available from our side as antimicrobial. So now if we look at the test method of reference to determine the efficacy or the performance of the product, as we mentioned earlier, against fungus, you have many different world standards or national standards which are available worldwide. American standard, for example, ASTM G5590. We have the TZ285 for Thailand, for example. In Singapore, the SS150. And in Japan, the GIS Z2901. That's to test fungi. And this is using the agar diffusion test method concept. And we will show you some example later. If we look at bacteria, you have the worldwide GIS Z2801, which is a Japanese standard initially developed for this application, but which is now translated to international standards organization, which is 22196 reference. And this is a worldwide accepted standard for antimicrobial surfaces today, and which can be applied for paints and coatings in general. And this is a quantitative method that's also very useful. Besides that, you have the AATCC 147 or the SNV 195-120, which is also based on the agar diffusion test method. Now, if we focus on the GIS Z2801 standard, you will see that the concept is using the, let me now use my laser pointer. So we have a suspension of 10 to the 5th bacteria cells per milliliter, and we have Escherichia coli on one side and Staphylococcus aureus on the other side. Two different types of bacteria. We have a test piece of coating, which is on filter paper, applied on filter paper to a certain thickness. And then we will apply the solution on the coating, one for each type of bacteria. And then we will apply a polyethylene film to maintain the solution onto the surface for 24 hours. We incubate for 24 hours, the test specimen plus the solution. And then after 24 hours, we transfer the solution back to the machine to check how many bacteria survived. So we start from 10 to the 5th bacteria cell per milliliter, and then we check how many bacteria survived. And this is how the test is done. 24 hours at around 30 degrees Celsius temperature. So that's the basic test. Now we look here at the results. We have, for example, a blank sample. This is one paint here without any antimicrobial product. So this is an unprotected paint. Here we have Escherichia coli. So we measure a log reduction. We start from 10 to the 5th, and then we go down to 0. So we have a complete log reduction in this case, and more than 99% reduction of the bacteria survival, and then we pass the test. So this is exactly the point. We do that against Escherichia coli and Staphylococcus aureus here. And in both cases, we have a complete kill of bacteria within the 24-hour incubation. So in this case, the product achieved its performance at 0.5%. More than 99% kill, actually 100% in this case. So this is just to show you the type of test for interior paint. Now, if we look, so that's the GIS Z2801. If we look at the fungi test, here we have an agar diffusion test concept. We see that the same paint without antimicrobial protection as fungi grows onto the specimen. So the specimen is completely grown. Of course, if we start to apply the antimicrobial product at 0.5%, we have a zone of inhibition around the specimen, and with a minimum leaching in water to simulate any cleaning or any leaching from the surface. And we see that it's a very nice result with complete zone of inhibition around the sample. So this is to show you the antibacterial test and the antifungal test for complete antimicrobial protection of the surface. Now, if we look at the next test, so here we compare a paint which is using silver antibacterial performance. This is not our product. And then we compare with immobilized BIT here in the same paint. So this paint here, of course, it's sensitive to bacteria, as you can see. So here we are testing against Micrococcus luteus and Serratia marcescens. So two types of bacteria, different tests, different bacteria, but similar performance claim, antibacterial. So the paint blank without protection is very sensitive to bacteria. The bacteria are growing onto the surface of the specimen. And the silver is not performing as good as per expected, of course. We have slight growth onto the specimen when immobilized BIT is really showing a good zone of inhibition around the specimen also, not only onto the specimen, but around the specimen itself. So we have a very good performance claim, of course, still with 500 ppm. We are comparing here 500 ppm silver against 500 ppm immobilized BIT. And of course, it's not the same cost in comparison. So just to show you different, this is another type of test. It's based on the agar diffusion test, but against bacteria rather than fungi. So now, if we look at the next test, in general, you can see the performance in general of different combination of immobilized BIT plus IPBC. You have also BCM in some case. In this combination here, you have also IPBC and BCM together. Those are, BCM is carbendazim. It's another fungicide which is available. And here you see IPBC, BCM plus immobilized BIT. You see the fungi test result. Here you see IPBC, BCM. And here you see competitor products for your comparison. And here the blank, the control, for your reference. And in all cases, with the same or slightly higher dosage, but still a better cost in use in general, we see the performance of our combination products. Now, if we look at the market trend, you see a comparison between actives for interior coatings, antimicrobial interior coatings. You see that zinc pyrithione, which is also another possibility in the molecules for this application. You see the comparison with silver against immobilized BIT plus IPBC. You see that in general, IPBC outperform silver and zinc pyrithione against fungi. Against antibacterial, there is a similar effect, but a better cost in use overall advantage for IPBC and immobilized BIT, and also a better stability in general. So overall, the IPBC plus immobilized BIT is really the most optimal combination package for complete antimicrobial protection of the hygienic coatings. So now, as a conclusion, we have immobilized BIT available as such. If you just want to enhance your product performance with additional antibacterial performance, normally we say between 0.3 to 0.5% to have at least 500 ppm immobilized BIT. The next option, if you want to have a complete protection of your coating or a product in general, is to consider all-in-one antibacterial and fungicide for interior paints, for example, or any other application which requires the same protection. And then you have immobilized BIT plus IPBC combined together for complete protection. And normally we say between 0.4 and 0.7%. All right, so now I would like to thank you all for your time, and I hope you can ask any questions later after this presentation. Thank you very much.